Okay, guys, good evening, guys. How are you all doing? Hope you are doing. Everyone is here. That's good. So I'm audible, right? I'm audible.
Yes, sir.
Okay, let me share the screen. Okay. So okay. Yes, guys. Today we have very interesting topics lined up. We would be doing three topics today. Okay, why it's not moving? Because I have not connected. Just 10 more seconds, please. Okay. So guys, today we would be doing. Today would be a rather what today would be very would be the beginning of something called as watershed moment in your mains preparation, right? Very reason being, we are working on something very innovative, and we know that there is a certain pattern, there is a certain way of writing answers for UPSC, and how we have derived that based on topper answers. When talking about the UPSC answer writing, we have derived that there is a pattern to write an answer based on topper answers and based on various education strategies and all, right? PYQs, the model answers to that, and so this set pattern, or what we can call it as hegemony, is continuing, is non-stop continuing, and there have been no innovations in answer writing, right? Have you ever thought about that? But we are in that cycle of just trying to figuring out what type of introduction should I write. Is my answer matching the demand of the question? We are stuck in that cycle, right? Virtuous cycle, not vicious cycle. It's a virtuous cycle only. But have you ever thought should we bring innovation in the answer writing itself? We are working on something very innovative. Nobody has talked about it. No research papers, nothing, right? We are working on creating very new, novel kind of answers. So this is for us. This is the Curiosity rover reaching Mars. This is that moment for us, right? This watershed moment for our organization. Such kind of innovation nobody has done before. So what is this innovation? We are going to transform your answers, right? We're going to transform your answers into groundbreaking answers, into very good answers. So why? The question was why 10 markers you have to expect. Even if you're getting 6 mark out of 10 marks, that's very good marking. Why not 8.5 out of 10, right? To majority of the questions, right? So we were doing that, and we are a research based organization. We are not an academy. So this is what we do on a day-to-day basis. This is where I put a lot of my brains, right, to do this. So what is this? What we are trying to do? We are trying to bring in something called as meta modernism, and we're trying to bring something called as counterfactual thinking, and we are trying to bring something called as narrative epistemology in your answers. So what are these things? These are not plug and play, okay? And these are not plug and play. You look at some toppers copies and you try to emulate it, plug and play basically. But this is not plug and play. This is a Darwinian moment where your answers have to evolve, and you as a person, as a thinker, right, from players, now you have become thinkers, right? You have to become thinkers. So as a thinkers, you have to evolve, right? Like Darwinian evolution, theory of evolution, you have to evolve. But we are here, we are working on that. So no need to worry. We have to. What you guys will be doing is you will be just following these things. What we would be introducing slowly, because it is not plug and play, right? It needs time, and we also need to understand how to provide it in proper morsels, so that you might feel a semblance of understanding, right? You should not feel intimidated by this. So that was the first announcement today. So we are going to create history, guys. That's what you need to know as of now, and we will step by step we will try to include these elements and more. There are more such elements in your answers, and make your answers absolutely stand out with respect to the competition. That's what we want to do. Okay. So today what we'll be doing today, we'll be discussing about the continental drift theory. Of course, we won't discuss the theory and all as if in the way it is given in the NCERTs and traditional books and other academies. We won't do that. And seafloor spreading, we would be discussing this as well. We'll be writing an answer or multiple answers, and we will be doing the plate tectonics theory. So I don't want you to make it more advanced at the absolute genesis of this session. So what we would do is, guys, tell me what do you all know about the continental drift theory. Let's start from the foundation itself. Then I will take you to better intellectual higher order thinking places. Okay. So you will be talking today, you will be talking more, you will be writing more today. So guys, come on, tell me, what do you know about continental drift theory?
So it was proposed by Wegener,
Okay.
and it said that there was a supercontinent Pangaea, which splitted into different continents we see today. Like basically, first of all, it was Gondwana land and what was
Angara
it?
land. Angara land.
Uh,
Angara land.
Angara land.
Yeah.
Laurasia, yes sir.
Okay.
I didn't read this word Angara land. And so like the ocean was known as Panthalacia, something like that.
Okay.
Yes. So
Okay.
it said that the continents are moving apart, but it was not taken as the right theory, correct theory, because of many contradictions were there.
Okay. My question is, was this the first instance when Alfred Wegener he proposed this theory of CDT, continental drift theory? Was it the first instance, or previously someone had done this before?
So he just summarized up different theories.
Okay, very good, very good. Do you guys know who was the first? Yes, ma'am. Yes.
Earlier, I think a map maker, a world map maker, had discovered that two different plates, basically two different continents, when
Okay.
they were knitted together, they formed actually like a joint plate.
Okay.
So I'm forgetting the name of the map maker. He is a very renowned map maker.
Okay. Okay. Okay, I think Angara land and Laurasia are the synonyms. They are using it as synonym. Okay, sorry, Monica ji. I get distracted.
Yeah, so sir, I think there was a map maker, a very renowned map maker, who had first given this theory that the different continents, when knitted together, they actually form a particular plate.
Okay.
And they got separated.
Okay. Okay. Wonderful. So you need not know these things, but why you need to know these things is because it shows that your genuinity towards the subject, right? You are not just reading, right? You are not just reading, you are not just lesson, this is a good lesson, you are not just studying, rather you are reading between the lines, right? You are going over and beyond what other aspirants are doing. That's what you should do. Okay, less of ranting, but let's see. It was first hinted by someone known as Abraham. You need not remember this name at all. Abraham Ortelius. In even I'm writing it from my notes. Even I don't remember this. But the thing is, the takeaway here, Alfred Wegener was not the first person, as Pranshu said. It was a culmination of what was said earlier. What to fix? Okay. So guys, tell me. You tell me, what were the evidences? What were the evidences for CDT?
So fossils found in different places, like fossils that were found in Ghana and in Brazil had the same sedimentary deposits of gold. There were deposits of fossils of plants and animals, especially of the dinosaur era, basically, which found similarity, and the way different countries had broken. So when it was knitted together, it formed a particular plane that all the shapes were knitted together well, and it was in proportion place.
May I be little bit rude today, guys?
Sure, sir.
Use less words when you're explaining. No need of telling all those things. You should have just told Mesosaurus, Glossopteris, Listosaurus. Again, see, I am. This is a hyperbole. Okay, I'm not being rude at all, but I'm talking about answer writing. When you're doing answer writing, you should always find that one phrase which can replace 7 to 8 words. And so when I was forgot about that story. So you have to try to do this, guys. You have to prepare intelligently. This is a lesson. So don't use too many words. Use fewer words. I'm not discouraging you to talk at all. This is just a lesson. So can you tell me what is this Mesosaurus?
It's a reptile, sir.
Okay, it's a freshwater reptile.
Yeah.
Okay, and Glossopteris?
It's a plant.
Plant. Okay. And what is this one? Listosaurus?
Shadow.
Anyone?
Is it a rat, sir?
Vijay, it's a reptile. It's a land dwelling reptile. I don't know whether it was a rat or not. What are the so this was the fossil evidence. Very nice. Thank you, Monica ji. What are the evidences, guys?
So the
Yes, anyone, no issues. Don't worry. You can talk over each other. One will stop.
So you're asking evidence, right?
Yes, sir. Evidence.
Sorry, actually, I started that just now only, sir. That's why I didn't get properly.
No issues.
Sorry for it.
No, guys, don't be sorry at all. You can talk over anyone. So we can talk, interrupt, and all. We can do that here.
Okay,
it is a safe space. Yes. Please tell me.
Sir, the zigzag alignment of the continent, that is eastern part of South America and the western part of Africa, sir.
Fine. Jigsaw fit of continents. Okay, fine. Okay, next one. Next evidence.
Tillite deposition, sir.
Wonderful. What is tillite?
It's a type of rock.
Sedimentary rocks.
Yeah.
Where it is? Where did you find this? Where are you finding this tillite deposits? Where?
Similarly, South America and I think it's in Brazil. Sir, actually, sorry, sir. It's in, I think, it's in whole parts of Gondwana, I think. Not sure actually.
Gondwana means you're talking about India?
No. I mean, like all the parts of Gondwana, it's including India, sir.
Including India?
Yeah.
Guys, do you agree to this? Tillite deposits were found in India as well? Firstly, let me, what it is, tillite means it's sedimentary rocks formed by glaciers, okay? These are rocks formed by the leftovers of the glaciers. Do you guys agree that tillite deposits was found in India as well?
Yes, sir. Like along with India, there was Australia, Africa, and many more.
New Zealand also, I think.
Yes, but now tell me, where do you find tillite deposits in India? Where do you find it? That is the question. This is how you should prepare. Tillite deposits in India. India में कहाँ था? You should think like that.
So
Should be
eastern,
around.
southern parts, sir, like east or
Okay.
south.
So
It's in Himalayas.
Okay. The thing was these tillite deposits. These are glaciers, and they were found in non-temperate regions. Like for example, they were found in the Talcher formation, the coal formation. I think Bhagat Singh was right. The Gondwana land. You will study all this, guys. Don't worry. The Talcher formation of Odisha and Jharkhand, right? It was found, and Satpura basin. The Satpura basin in where? Madhya Pradesh, right? And I'll tell one word, one valley. You have to tell me in which state it is found. Damodar Valley. Where, guys? It's found in West Bengal and Jharkhand. So your preparation should be like this. This should be your preparation. So the MCQs, you are looking for the MCQs, that MCQs will come like this in 2026, and we are predicting 2026 to be the most toughest prelims paper in the last decade. So people were saying 2022 became difficult, 2023 became difficult, 2024 was most difficult, 2025 was most unpredictable, 2026 would be a Terminator kind of paper. So this is how you should prepare. This is the lesson, guys. TK. Now I'm searching for a question. It was in my notes. It was rather very good question. Fossil evidences, yeah, है ना? And we have a lot of evidences. So we'll stop this fundamentals here, because this is found in all the books. We have to let's go to the higher order thinking, right? We just made the fundamental thinking. I'm looking for one very good question. It's in my notes actually, and then we'll start writing answers as well today. I got it. I got the question. It's a thought experiment. We are here to do the thought experiment, right? And to develop our what will we propose when we pitched you guys about the second month program. You'll be developing analytical thinking ability, critical thinking skills, right? That is the thing. So now the question is, you guys will not write, but you guys will brainstorm on the paper, pen and paper. Then we will discuss about this answer. What question is, what if the continental drift had been accepted in 1912? Think out of the box. 2 minutes. Okay, guys, think about it. Guys, yes. Let's stop because we have many more answers to write. So guys, tell me, anyone tell me, what do you think?
So we would be
Shall I, sir?
Sure. Go ahead.
Sir, but it's actually it has some flaws. Even though after that, after all the scientists have been discussed, I think from my point of view, I'll say like there is no we cannot able to explain the thing of mid-oceanic ridge. I think.
Wonderful. So we were not explaining in the continental drift theory. We explain it in the seafloor spreading theory.
Yeah.
So what if and seafloor spreading, it came in the 1960s, right? In the mid of the 20th century. But if I'm not wrong, so guys, tell me, what would have happened if continental drift theory was accepted in 1912?
So we would have not ever understood why exactly the plates are moving further, or why is it in the divergent process, to be simply said.
Yeah, that we understood only in the seafloor spreading, right? Until then, we didn't understand it. Let me just cross check the year. It must be the 1960s, seafloor spreading by Harry Hess. Harry Hess, 1960s. Okay. So it came in 1960s, but what happened between these years, and research was happening basically, right? That submarine research and all. Post World War II, we find something a ridge between the continents of Europe and the continent of the Americas. We find that. But what if the continental drift theory had been accepted back in 1912?
So we
might
would
have
have accepted.
We cannot. Yeah. Go on.
So we would have accepted the theory of tidal force, and according to which the moon's gravitational pull was the reason. And if that was acceptable back at that time, we won't have come to the point that mantle is the reason behind this. The
Okay.
convection currents from mantle, and also the reasons, the phenomena of volcanoes and earthquake.
Wonderful. Yes. Please go ahead.
Yes, and also, sir, many archipelagos are there, so we won't be able to like we would not have been able to find the reason. Like Philippines and all these islands are because of the seafloor spreading.
Right.
So we like many phenomena would be uncovered, sir, if we
A-
would have
ab-
accepted this.
Absolutely right. So if we summarize what you guys told so far, can we summarize it like earth sciences would have advanced 50 years earlier, before this seafloor spreading theory and the plate tectonics in the 1960s, right? What would have happened if this was accepted, if continental drift theory was accepted? Further research would have been done. So it was basically ridiculed, है ना? Why it was ridiculed? Because it didn't provide any mechanisms for explaining, right? Why the mountain, why the continents are moving, right? It was ridiculed for that. More importantly, it was ridiculed because he was a meteorologist, right? He was a meteorologist, and he's telling geologist, he's teaching geologist how the continents are moving. So he was ridiculed because this is, we can call as academic silos. We'll just discuss. Give me just 2 to 3 minutes. We'll come there. So if at all the continental drift theory, with all of its flaws, if it would have been accepted, we would have the scientist, the geologist would have identified or discovered the plate tectonics earlier. Can we say this? Earlier. So it would have been, so the plate tectonics itself, the plate it is advanced class, guys, don't worry. Plate tectonics could have been formulated in the 1920s only, or 30s only, as as Pranshu said, understanding of earthquakes, volcanoes, है ना? We would have understood it earlier. So what would have been the impact? Impact क्या हो सकता था? Impact would have been very good impacts. Early hazard mapping in Japan, Italy and Turkey. Now it is Turkey, right? And better. So your answer should be like this, guys, not very static. Better urban planning in seismic zones. And very important, for the very important impact would be the second impact. I think it was Bhagat, he was saying, he was talking about mid-Atlantic ridge, the expeditions to the mid-Atlantic ridge could have begun in 1920s only. So we realized there is something called as mid-Atlantic ridge. There is a mountain, some of whose peaks are taller than Mount Everest. We realized it when the submarines in the World War II, post World War II, they ventured into the oceans, right? The testing of the submarines. So expeditions to the mid-Atlantic range would have happened in 1920s only, right? So what it would have become a scientific frontier rather than a military one. So we are bordering essay writing also now. So it would have shifted from war to wonder. What? The oceanography, right? Oceanography revolution would have come early, right? It was shifted from war to wonder. What? The ocean mapping. Cool points, right? Nice points to write in answers. Okay. So there are many such points, but one point I want to discuss here. This is rather interesting, an intellectual point. The geopolitical maps would look different, right? How? Colonialism in 1912 was in its peak, right? If these scientific advances would have taken place post continental drift theory, if it was accepted in 1912 only, and you would have understand that the colonial countries would have understood that the continental connections and shared geological heritage, right? So would the resources in Africa, Africa's resources, which was claimed like a cake by these colonial countries, it would have been claimed differently? How could they have understood common earth systems, right? There is a term in environment, the common goods. It is for everyone, like fresh air, like lake, like forest, right? It is for the common earth system, and so things would have been changed, right? So this is what. So we are not saying you have to study like this for. Yes, Monica. It is recorded. It is recorded, Monica. But I think the screen is not recorded. It is recorded in a podcast form. I am still facing technical difficulties. That's why. So where was I? So I'm not telling. We are not telling that for every topic you have to study like this. It is impossible, right? We don't have that luxury of time. But to some topics, at least some topics, you have to choose, pick and choose based on the PYQs. Some topics where you want to score, you love those topics, you can do this. And for instance, what are those topics? You can ask me. In Indian society, every year there is a question on women, or at least every alternative year. Every alternative year there is a question on the features of Indian society, like multiculturalism, family, marriage, etc. So some topics, if you pick and choose, and ethics topics, easy to score, right? So if you choose and prepare like this, it will, you'll be in a better position. Now let's write an answer. Okay, now let's write an answer. The question, I'm searching for that question in my notes. A decent easy question let us take, and let's write an answer to that. Okay, the question is why was the continental drift theory initially rejected, and how did my brain just skipped for a few milliseconds. How did it later shape our understanding of Earth's geophysical processes? 150 words. Remember few things. You have to write an answer to this. You can take not more than, guys, we have to complete it by 5 minutes only. So you can write a structure rather than writing an entire answer. A structure, okay, a structure, an intro, body, few points, structure only, phrases you can write. Remember the DNA, the language of geography. That's why we are here. We need not write mediocre answers. And the diagram, every question, geography question, one diagram should be there. Remember this and start writing an answer, guys. Let's go. हेलो, हेलो, हाँ सर बोलिए सर, आदिल सर। गुड इवनिंग आदिल सर, अभी मैं क्लास में था, बहुत क्लास चल रहा था, क्लास के बाद कॉल करो आपको। कोई नहीं सर, कोई नहीं। धन्यवाद धन्यवाद सर, धन्यवाद। मैं कॉल करूंगा सर आपको। बिल्कुल सर, आप जब भी फ्री हो जाऊंगा मॉर्निंग में। कितने करोगे सर? डन डन डन, कितने बजे सर? डन सर, आई विल बी फ्री, मैं फ्री हूँ बस, तब कीजिए सर, आप कीजिए। थैंक यू सर, थैंक यू। गाइस डन, प्लीज शेयर इट। नहीं हुआ तो स्टॉप इट गाइस, स्टॉप करते हैं, शेयर करते हैं व्हाट्सएप में। बट गाइस बिफोर यू शेयर इट, शेयर कर सकते हो। डू यू नो अबाउट दिस थिंग कॉल्ड एज स्पेशियो टेम्पोरल aspect? Do you know, anyone knows about this?
So I have heard but not know that exactly.
Yes sir, no issue sir. Spatio means space, spatial dimensions, they say spatial dimensions. It is the location, right? The location of a geography, right? And temporal means time. It is about time, it is talking about time. So 200 million years ago, when Alfred Wegener is saying it started disintegrate, there was a continent called Pangaea. He's talking about time, temporal aspect. And spatio, he's saying that India and Australia were a single continent. Angara land, or sorry, Laurasia or Angara land, same thing. And Gondwana land, they located here, right? They located here. Then Panthalassa, right? It formed a rift valley here. Ocean started getting formed and they started diverging. Where it is, he's talking about the location. This is spatial aspect. So you need to use such terms called spatial temporal aspect when you are writing geography. That's what we are saying, no? The DNA of the geography. So don't fall into the trap of write in a general manner in your day-to-day wordings you write. That was true until the time of I forgot that topper's name, very famous topper, Anirudh Durushetty sir. Anudeep sir. Then it stopped over there. Post that it has become quite complicated, and toppers have been writing very good optional level phrases. Some phrases they are using, but not necessary at all. You can still construct good answers. So okay, now let us look at this answer. Let us first write it, then I will look at your answers. Let me just tell you how you should write it. Okay, firstly the DNA of geography we will be using. We have to begin with an introduction. The question was what? The question was why was continental drift theory initially rejected? They are talking about something rejected. Okay, and how did it later shape our understanding of Earth's geophysical processes? So you might pick and choose what type of introduction you might want to write. Let me write a generalistic definition. Okay, and I want to, so there are two components here in this introduction. They're talking about two components. Let's first write the first component. They're talking about continental drift theory initially rejected. Okay, and second question is, I think this is the question only, right? Yes, this is the question. And the second question is, let me just cross check. Okay, right, this is the question. So, and the second part of the question is, how did it later shape our understanding of Earth's geophysical processes. Okay, fine. Very difficult question, again, very difficult question. That's why we have taken it. So as it is a 150 words question, I can write introduction of only one sentence or two sentences, not more than that. If it was 250 words, I would have written at least 3 to 4 sentences, minimum 2 to 3 sentences I would have written. Then I would have brought in both these phrases in my introduction. So I will pick and choose which to bring, right? So I will write a brief introduction, what is CDT at all, and I will bring in this thing, how it shaped the Earth's understanding of the Earth's geophysical process. So let's begin. Let's write. So continental drift theory. This is the introduction I am writing. I am writing intro. You guys need not write in your answers. Directly write the introduction, because this is taking up the words, right? The word limit, it is eating it up. Don't write introduction at all. So the continental drift theory, CDT, it was proposed by Alfred Wegener Sahib in 1912. So what it did, so now I'll tackle this aspect in my introduction. So what it did was it marked a paradigmal shift in the geophysical processes, in the spatial understanding. I'm bringing this term, spatial understanding, because this is a geography term, right? We want to make it more geographical, our answer. Spatial understanding of lithospheric evolution. That's what happened, right? How the continents are breaking up and moving. Lithospheric evolution across geological time. So this is what is happening, right, according to continental drift theory, right? So paradigmal shift is just, what did CDT do? It gave some theories, right? It gave some theories that continents are moving apart, but it didn't provide the mechanism. And this mechanism was brought in later by seafloor spreading theory, right? Earth's geological processes were later understood. It helped to shape and understand the Earth's geophysical processes later on. That's what. So the CDT given by Sir Alfred Wegener in 1912 marked a paradigmal shift in spatial understanding, the space and time, spatial understanding of lithospheric evolution across geological time. This is my, we can write it spatio-temporal understanding of Earth, about the mid-Atlantic ridge, about earthquakes, about volcanoes. Because of the CDT, it was the genesis. CDT came first, then seafloor spreading comes next. So there are two questions here, as we discussed, that is, why was it rejected? Question 1, in the body, the first answer, you need not write again A, you can write, why was it rejected? Why was it rejected? As Bhagat Singh said, it was rejected because it has some flaws. So we can use cause and effect, that is, absence of driving mechanism. As Pranshu had told, that tidal forces between the moon and the earth, it caused, and gravity, these were the reasons given for movement of the continent. These were very weak reasons, right? Tidal forces are not strong enough to move the continents at all. So he said that continents are moving, which is true, right? Which was later on proved by plate tectonics and seafloor spreading theory. Okay, no issues, Monica. So but he didn't give a proper driving mechanism, like he didn't add knowledge of convection currents, right? There was a question as well about mantle plumes. So it didn't give the driving mechanism, and it contradicted. Why it was rejected? It contradicted the contemporary static Earth paradigms, right? Again, you can, this is model answer, you can write it in your own words to make it look like more general studies answer. That is what used to happen in those time. The geologist believed that the Earth's continents are static, right? They are not moving, as proposed by Alfred Wegener and many others prior to him. Okay, and what actually, why was it rejected? We are answering. Wegener was he was a very talented person, very intellectual person. He had cross disciplinary background. He was a meteorologist, so it is nothing to be ashamed of. I use the term but he was a cross disciplinary, he had a cross disciplinary background, nothing to be ashamed of. But the academician, the various geologists of that time, they didn't accept it. This weakened his own discipline, weakened acceptance of this theory within the geological orthodoxy. Again, we are using very complex terms and all. You need not, you can write it in a general manner, but you need to use some terms like convection currents, driving, what was the driving mechanism, static earth paradigms. You should be using this, then only it will look like a geography answer. So this was why it was rejected. Further we can write lack of instrumental validation, right? Like paleomagnetism, which was used in the seafloor spreading theory, right? And again, bathymetric data, right? This sounds like an optional answer, but you can at least use paleomagnetism, right? It is there. Paleomagnetism is there in the NCERTs, class 11 NCERT, it is there. So this is how you can answer the paragraph A, that is the first part of the question, that is why was it rejected in the first place. Now let's answer the second one, the most important one. How did it shape the modern understanding, right? What it did, it laid the foundation for the plate tectonics theory, right? And the plate tectonics theory further explained orogenesis, seismicity. These are all NCERT terms, volcanism. So it laid foundation for this. So, and it enabled integration of geomorphological and paleoclimatic data. These terms, again, chapter number 1, the various academics or various streams of geography. So you have to, if you have read that, you could have used these terms. So it informed, later on it will inform models of continental configuration. We understood that yes, it was proved later on that yes, there was something called as Pangea. It was proved, right? So now we have answered the body part. Now let's come to the conclusion.
So what you have written in the second point, the last word?
Yes. Sorry. It enabled integration of geomorphological paleoclimatic data.
Okay.
Okay. So let's write a conclusion for this. So let's write a conclusion. So this is the most top level higher order answer. It should easily fetch you more than 6.5 marks. You are not expected to write such answers, right? Not at least now, right? What we can conclude synthesis of contemporary relevance also we should bring, because this question is asking about the future of the Earth's geophysical processes, how CDT itself helped understand further. So we have to bring some futuristic elements. So we can say from an initially contested hypothesis, continental drift theory evolved into a spatial theory unifying Earth's dynamic system. Fine. Nothing too complex, too complicated. Simple terms we have used in the conclusion. Okay. So this is how you can write. But the most important thing which we discussed yesterday, try to bring in that image, that map or diagram. But the challenge is you have to draw this diagram in 30 seconds. It is a 30 seconds challenge. So let's define everything in this webinars. Okay? So what is the challenge? Challenge is you have to bring everything, the diagram, in 30 seconds. That is the challenge. So how you could have drawn? So I would have drawn something like this. You cannot draw the earth and maps. You can do that as well, but I would have drawn something like this. This is Pangaea, and for further information, 250 or 200 million years ago, and Eurasia went this side, North America went to the northwest, and South America went to the southwest, and Africa, India, Australia travel to the southeast. Now you will, most important thing, you will write figure image showing continental breakup from Pangaea. Enough. So you can draw within 30 to 50 seconds. You can draw it. Not a big deal. So somewhat we are explaining through a diagram. You are using a diagram as well. So now let's go to your answers, guys. So Spranshu, again diagram, very good. The continental suggested that all continents once formed single land Pangaea and surrounded by ocean Panthalassa, which later split into TK. She is answering the first question, first part of the question. Done. It was initially rejected because tidal force Wegener gave the reason to gravitational pull of the moon and sun and moon, and centrifugal force due to Earth's rotation. Good. On point, it later shaped many geophysical processes. The earlier evidences were from continent areas only, which was incapable of explaining many theories, but it led to, okay, it later shaped many geophysical processes. TK. Okay. Seafloor spreading. Okay, so she has answered both the parts. Plate tectonics. The new theories just change the way to teach the same. Very good. I like this one. I like this point. In place of good understanding. In place of tidal force, a thermal convection current. Very good. Geography looks like a geography answer. Were introduced to explain pulling and pushing forces. In place of centrifugal force as the driving force, volcanic eruptions entered. Okay. Scientists just sought to unify the theory explained by very good. Plate tectonics was a unifying theory. Okay. Wonderful. I would give this answer something more than 6 would be too much. Somewhere between 5.3 to 5.7 we can give. Okay. Let's go to the next player's answer. Monica G has written an answer. Let's see. Continental drift theory suggests that there was one landmass stitched together, that is Pangaea and Panthalassa. Pangaea was supercontinent and Panthalassa. So similar introductions you both have written. Coincidence. Okay. However, this theory was rejected because the first part of the answer, lack of evidence of the continent's movement, lack of mechanism. Evidence is fine. Lack of mechanism as how to actually happen. Very good. Let's okay. later shaped our understanding of what's a geophysical. Okay, 2 points. Okay, fine. Plate boundaries theory, divergent convergent boundaries, lithosphere, wonderful. Ridges, movement of oceanic. Okay, fine. Again, more than 5. I would give more than 5 only to this answer as well. I think this is Manasa's answer, if I'm not wrong. Why is Manasa not in this group? This is Manasa's answer or Bhagat's answer? I'm not sure.
So it's my answer.
It's Bhagat's, right? Yeah, that's why I recognize. Yeah, I recognized it. So very well structured, pleasing to the eyes. That does not mean again, Pranshu had that doubt. Should we make it more presentable? Should I work on the handwriting? It doesn't mean that more presentable means more marks. It doesn't mean that. But it is just pleasing. I just made a statement. As the continental drift theory was proposed in 1900s, but due to some pre-criticism, the old scientific community didn't accept it. That. Okay, let's read further. Rejection, reasons for rejection: unable to justify what happened before. Good, not considering ice age. Okay, forces which moved the continent far. Okay, future reshaping, acted as a base for upcoming studies. Wonderful, acted as a base. Good. Futures. Okay. So there is a diagram as well. Good. Okay, we can give more than 5. As being there is a lot of conflicts with it, but it paved. Okay, we can give more than 5. We can give easily more than 5. So I'm not, again, deep dive. I'm not going doing the analysis here. This is Manasa. So Manasa is, I'm seeing Manasa's answers for the first time. He was proposed. Continent. He said, okay, were once together and they moved apart eventually, and proved it with some proofs like, okay, good. Why was it rejected? Because it okay, he failed to explain the process period. Good. It's theory existing scholars understand. Okay, good. It helps us understand. Very good. First answer I will not give the marks, but okay guys, you have understood. The assignment, how to write. You guys, all of you have written it well, right? Okay. Now let's go to the second one. We'll quickly complete the seafloor spreading. Let us understand what is the seafloor spreading. Quite conceptually, let us understand. The sea flow spreading. After this I will give you one assignment, very small assignment, 2 minutes assignment. Sea flow spreading, what happened, what it said basically was earlier the ocean flow, you know all these things, ocean flow. So quickly let's, ocean flow was imagined as static, okay, and lifeless rather. Okay, so with the discoveries of the mid-Atlantic ridge, and the most important term you have to use when you're writing seafloor spreading answer is the symmetrical magnetic striping. We'll understand what it is. You guys know as well. A new narrative emerged that Earth is dynamic even in its deepest places. Earlier it was thought that the ocean floor is a passive basin, but post the sea floor spreading, what it did was it said that no, ocean is not a passive basin. It is rather a crucial factor in the lithospheric dynamics. Again, an interesting term. Why? Because concepts like tectonic plate, concepts like ridge, concepts like trench, right? These terms were discussed in research papers and in the halls of academic places before as well, but they were re-engineered. Good term, re-engineered post the sea floor spreading, because it was not just descriptively explained, but explanatorily, right? They explained it in a much better manner, right? So it redefined the foundational, all these foundational terms. So this is about some things about the seafloor spreading. But what I want you to do is, I want to answer this question, brainstorming question. Don't take more than 90 seconds. How do you link the continental drift theory and sea floor spreading theory, sea floor spreading hypothesis? How do you link it? What do you understand? How do you link it? How these two are related? You can take 60 seconds, 60 to 90 seconds and answer.
So can you repeat the question? Sorry, it just broke for me because of internet.
Sure, ma'am. Sure, Monica. The question is, how do you link the continental drift theory and sea floor spreading? I'm asking this question because all this seems abstract, right? Because why does it feel abstract? I'll tell you why. Because we are reading some random events from the geological history, right? Some 250 million years something happened. Post that, what happened? We don't know. Again, now we are jumping to 1912, then we are jumping to 1960s. So it all seems abstract to us. So we have to understand, this is how we read. It is called as first principles thinking. This is how we have to study first principles thinking. Break down the concepts into its fundamental units and start learning from there. So that's what we are doing. How do you link the continental drift theory and the seafloor spreading hypothesis? How do you link it? How they are related? Or can you I will ask, can you compare and contrast?
So the sea floor spreading laid down the sea floor spreading led to the plate tectonic theory,
Okay.
and that was the compilation of different theories like continental rift and like earthquakes, volcanoes, and everything. So in that way, they both are related. If
Okay.
we want to compare, but if I want to explain, then I can say that the like in continental rift theory, the conclusion was that the continents are moving apart, and in
Correct.
seafloor spreading, it said that there is new ocean crust formation, and it
Correct.
showed different proofs which prove the same thing.
Absolutely right. That is the answer. But let us frame it in a in a better way, in a formal way. The continental drift. Yes. Someone wants to come in.
There is an evidence, like a complementary evidence, that is said that the age of the new crust that is formed in the seafloor spreading is younger than the continental crust. In that way, it is a complementary evidence for both of the
Ab-
linkages.
Absolutely right. Absolutely right. Very good, Monica. Let's put it in a formal way. The continental drift theory was the hypothesis, right? It hypothesized that there was a supercontinent named Pangaea and drifted apart, whatever. But the problem was, what was the problem? No mechanism was given. No mechanism was given to explain how continents could move, right? What pushed or pulled them? What the sea floor spreading did was, it filled in this missing mechanism jota, right? That is missing mechanism jota. It provided that missing mechanism. That is it provided the mechanical process that the continental drift theory lacked. Now let's make a table. Compare and contrast question. We have to make a table. So let's make that table. How they link continental drift and sea floor spreading. It described what was happening. It described what was happening. It described how it is happening. How it is happening, we'll see now. Most important one, it focused on the continental moment, right? This one focused on the oceanic crust formation and its motions. This was theoretical and incomplete. It was empirical. It was empirical. Why empirical? We'll show now. The magnetic evidence. It was empirical and mechanistic. The actual happening, the actual movement was recorded. The actual movement, as Monica said, that oceanic crust was being formed near to that ridge, near to that ridge where the magma is coming out. New crust was formed. Constructive boundary was formed, right? So that we got that. So it was again CDT was rejected. Why it was rejected, we know, for lack of mechanism. And this was why it was accepted. The most important, it gave strong geophysical evidence. Geophysical evidence. So this is the link between these two. NCERT misses this link. So NCERT actually seem very mechanistic and abstract in nature because these links are missing in the NCERT. So now let us little bit deep dive what actually this seafloor spreading was. There is something called as I just want to discuss that magnetic evidence. Mid-Atlantic ridge, a little bit of introduction. Let's give what it is. If you can define what is mid-Atlantic, you have to define everything. It is a massive underwater mountain range running down where at the center of Atlantic Ocean. And how it looks actually, if you want to visualize this, have you guys seen that cork ball? They say that cherry in test cricket, they use that cork ball, cherry, hard ball, they say. There is a seam on it, so it is nostalgic for us. When we were young kids, we used to get this for 99 rupees, this hard ball, that red ball, and it has a seam at this center, something like this. And if you hold your fingers at this seam, and you can actually control the movement, the in swinger, out swinger, it looks something like this. The mid-Atlantic ridge, it seems something like this. So what it is, what it is, so we just visualized how it looks. So is it a mountain? It is not just a mountain, it's a divergent boundary. Did I do a mistake? No, I didn't do a mistake. It's a divergent boundary. What it is? It is a divergent boundary. Yes.
Sorry, you're talking about the ridge creation through magma?
Yes, absolutely, ma'am, absolutely.
So this is divergent boundary only, sir, right?
Yes, ma'am, yes. It is divergent boundary. It is divergent boundary. So what about happens in divergent boundary? A new oceanic crust is being formed. So a new land is being formed. Okay, this is the introduction of what actually, new land is being formed. Introduction of the mid-Atlantic ridge, the seafloor spreading theory. What happened? So the magnetic stripping, I want to talk about this. I'm more interested in this. The magnetic, we'll take a question on this as well, but it is already late. Magnetic stripping, what it is? It is on either side of this ridge, like this. It is showing alternating bands of magnetic polarity, just like barcode. You might have seen barcodes, right? It is like barcode. So what it is, let's try to simplify this. What actually happens? Hot lava comes out from deep inside the earth, and once it reaches the surface due to the ocean, it is under ocean, right? The mid Atlantic ridge. It cools down and becomes solid rock, right? And inside this lava there is inside this lava you can find this tiny iron minerals, like ferrous minerals, and it looks like compass needles, and these minerals they actually align themselves with Earth's magnetic field, right, as the lava cools down. And the twist is, there is a twist here. The interesting twist is the Earth's magnetic field, what it does is it flips every 100,000 years. Sometimes the north is north and sometimes the north is south, and hence when it is flipping, right, this alignment of these iron minerals also changes. Hence we have that absolute evidence recorded in time that Earth is opening up and magma is coming out and new crust is being formed. This is the significance. So what happens here? Let us summarize it, what actually happens. And these stripes, these magnetic stripes, they are symmetric on both sides, that is mirror image barcode like structures are formed. So what is the conclusion of this? Conclusion is new crust is constantly forming, okay, and old crust is pushed aside, as Monica was saying, right, that is spreading the sea floor, right? And this isn't this exactly matches what Wegener guessed. He guessed it, right, gave an hypothesis, but he couldn't prove. So this is what that is, the continents are moving apart, but he couldn't provide the evidence why it is moving. So let's take a question, and I will only try to frame a small structure for it because we are having lack of time. The question could be sea flow spreading provided the much needed mechanism to validate the continental drift theory. So the question goes on further, explain the sea floor spreading and its significance in understanding Earth's lithosphere dynamics. Right, we can write a introduction, right, like what could be an introduction? The continental drift theory proposed by Wegener, it was compelling, but it lacked evidence. Evidence on a geodynamic basis. But sea floor spreading, as conceptualized by Harry Hess, it operationalized this drift like a conveyor belt. It's operationalized this drift through a new crustal formation along mid-oceanic ridges. Okay, the process itself you can explain in this question. Explain the seafloor spreading, that is divergent plate boundaries, basaltic magma emerges at fractures through the fractures at mid-oceanic ridges, and paleomagnetic reversals recorded in this magnetic striping. Then significance, significance is it validates. It validates what? It validates Wegener's, Alfred Wegener's theory. Okay, and most important thing it was, you will be using these terms in your answer writing as well. It linked the lithosphere, asthenosphere interactions, right, to mantle. There is a wonderful image of this in the NCERTs. Mantle convention currents. So conclusion from hypothesis to unified theory, it provided. You can conclude like this. And diagram, you can 30 seconds, in 30 seconds you have to draw the diagram. I would have drawn something like this. So you can generate diagrams like this for every topics in geography. You need not draw these many bars as well. So you can show this as ridge, mid-oceanic ridge. Okay, and you can show, as Monica was saying, this is the younger crust, right, but it is diverging. You can show it is diverging. Here you can show older oceanic crust, same older oceanic crust, and you will write, this is the most important figure. You can write seafloor spreading, simple, seafloor spreading. 30 seconds you can draw this. Only if you have this image already in your notes, only then you can draw it in 30 seconds. So final thing we have to discuss today is, we'll wind up now, plate tectonics. It is a theory, scientific theory, which says that Earth's lithosphere is divided into several large and small tectonic plates. This definition is very important, that move over semi-fluid asthenosphere. So this term is very important when you are writing plate tectonics answer. Asthenosphere. Driven by what? Driven by internal heat and mantle convention. So doesn't it encompass everything that plate tectonics want to convey, right? So there are some terms here. What are plates? If someone asks, so these terms you have to make a dictionary in your notes, like it should be like a dictionary. Every term's definition, it should be there. Only then you will revise it again and again, and those terms will reflect in your answers. So this is how we have to do. Plates, what? It is a rigid slabs of lithosphere. Example you can write. Example when you are writing answer. Example, Indo-Australian plate. Again, what are the major plates? 7 major plates. Various minor plates you will be learning when you are studying for prelims, not now, right? Plate. And it talks also, this tectonics theory talks about different boundaries, right? Like divergent boundaries, right? When you are writing divergent boundaries, you have to give examples as well, otherwise your answer looks mediocre. Mid oceanic ridges convergent boundary. Can you give example? Trenches, like the Marina trenches, mountains. Okay, then the transform boundary. I hope you know the difference between these three, and if I give an answer, you can compare and contrast between them. But the most important one thing we will discuss, and we will take a leave over here, the driving force. Can you tell me the driving force for this plate tectonics? We are functioning at a very advanced level here. If there was a beginner aspirant, he or she would struggle, and let us struggle, right? We don't want this to be class of another NCERT. ऐसे classes पढ़े हैं YouTube में, भरे पढ़े हैं. We want you to do analytical thinking. I want you to suffer now. I want you to be feel alienated now, and multiple times you feel alienated. One day after 6 to 8 weeks, you get accustomed to these classes. Then what? Accustomed to these classes, that is the difficulty level. And the questions, you just open the recent last 3 to 4 years mains question paper. The questions are so difficult, let alone answer. You will take lot of time just to understand what is the demand of the question. So that's why these classes are difficult. Otherwise, this difficulty will not simulate. This difficulty it will be simulated for the first time in the exam hall. That is a very wrong way to do. Okay. So what I was saying, I forgot. The forces itself. Can you guys tell me, answer this question? What are the driving forces for plate tectonics?
Sir, it is friction, and due to which the pressure, due to the exerted pressure, so the from the fault lines, the magma comes out as lava. And so another factor is flux melting. So
Very good.
what happens in that is yes, sir. So like the underlying the underlying mental wedge, it releases water, like because of which the magma on the upper like the subducting plate is having that like releases water, and that water enters into the upper plate, we can say. So like that lowers down the melting temperature of magma, so it melts and it comes out as
Okay.
lava.
Very good. Anyone else? Last chance. Yes.
Sir, when it comes to SL, I'll accept that Pranshu, and she said pressure is the indicating factor to act as a driving force, and also I should add something to it. And I mean, heat forces internal heat, which
Wonderful.
am I getting, sir?
Yes, absolutely right.
The internal heating makes it even more possible to drive the plates away or connected.
Absolutely right.
Yeah.
Absolutely right. Wonderful. So the question was the mechanisms of plate motions. What is driving these plates? So there are several reasons. We can discuss the three main reasons. That is the mantle convection. This is what the internal heat, both Pranshu and Bhagat was talking about. The internal engine. This is the internal engine of this plate tectonics. What it is driving. Okay. So what happens? The hot material deep inside the mantle, from the mantle rises. Why it rises? Because it is lighter, right? It rises, then it spreads out, then it cools, and it sinks again. It creates a circular flow. There is a very good image in NCERTs. It creates a circular flow, just like boiling water, right? So what happens because of this? Okay, it is doing something, it is creating a circular flow. So what happens because of this? What happens is this slow movement of the mantle plume or convection currents, it drags the lithospheric plates. It drags it, sitting on the top of it. Here is a lithospheric plate. It is dragging it. Can you see that? Can you observe this? It is dragging it out, right? And these plates, that is the continental plates and oceanic plates as well, these plates ride on the mantle conveyor belts. Understood? Like a conveyor belts. It is riding, these plates are riding. This is the first reason. So this should reflect in your answers.
Sir, I have a doubt, sir.
Please go ahead.
Yeah, sir, as you mentioned, like conveyor belts, it's a kind of utopian term with respect to Earth, right? I mean, like in currents. Can we use the term conveyor belts with regards to that?
Yeah, I'm thinking about it. But we are trying to understand it. That's why we are using this term, conveyor belts.
Yeah, but okay, but we shouldn't use it like in answers, right? Or shall
We are giving a metaphor here. You can give metaphors. Nothing wrong in that.
Okay.
Right?
Okay.
Okay. So good question. Good. You guys are very good. You guys put me in the spot. Very good. So second one is ridge push. So to not a complicated, bear with me. I will complete it. Will not take more than 5 minutes. We'll end it here. Gravity at work. The ridge push. What is happening here? Let us understand. The mid-oceanic ridges. We understood that new crust is forming, and this new crust is elevated because it is less dense, right? As it is less dense, right, it is elevated, fresh material coming out, it is still hot, piping hot, less dense, so it is elevated, it is little bit elevated on the mountain, right? Ridge means mountains, right? It is forming a mountains, so it is elevated, and what happens after that? It cools down. After some time it cools down because of the water, it's inside the ocean, it cools down, and after cooling down anything becomes denser. Basic physics, right? It becomes denser and slides downhill under gravity. So effect, what it is happening, it is the pushing force. These are pushing force, pushing the plates. It is moving the plates away from the ridge. That is what is happening here. The effect, what is the effect? Again, these are very complicated. You need not there won't be a question asking you to explain all this, but you will be using these terms to enrich your answer. That's why we are discussing this. So what happens here? Because of that gravity, that new crust, new material will come out. It is going up. It is elevated because of it is light in nature and it is piping hot. After it is cooling down, it will become very heavy and it will move down, slide down. So what is happening? This every new crust that it is being formed, it is pushing out. It is pushes the older crust outward. Now Monica had said that we have this evidence of the newer crust being formed at the ridge and the older crust away from the ridge. Now we know why. The reason is it is called as ridge push. Okay, these are some of the reasons. There are several other reasons, but these are some of the reasons. So what it happens, let us write it down. The mantle convention, it happens beneath the lithosphere, right? That convention, what is happening beneath the lithosphere, it is forming this convection currents, and due to this the plates are following the path of this convection currents and drifting apart. This is happening beneath the lithosphere. The ridge push, it pushes the plates apart, right, at the mid-oceanic ridges. So I wanted to show one diagram here. I don't know where it is in my notes. It should be somewhere. It was a good diagram explaining the plate tectonics. If you get a question on plate tectonics, you can draw this diagram or something similar to that. You can draw, you can show this. It is mid-oceanic ridge. This is mid-oceanic ridge, and it is divergent. You can write it. It is divergent. This is plate A, and this is plate B. This is plate A. This is plate B. Right. So one of the plate will subduct because it is made of magnesium, that is Cm. The oceanic plate will subduct. Okay. You can show this. It is the subduction zone, that is convergent plate boundary. It is right. So this way you can also show this is asthenosphere. Right. You can draw a diagram something like that. Again, you will write figure showing plate tectonics, major boundary types. So I would like to end this webinar over here, guys. Hope it was helpful, and hope we understood a lot of things, right, regarding what we understood. Let's summarize. Guys, if you have any questions, first you can go ahead and ask the questions.
Sir, I have. Can you please explain that diagram once more?
Sure. I will explain this diagram. So these two plates moving apart. This is what happens at the mid-oceanic ridge, right? It is a divergent plate. So you can also draw your. So this plate A is moving to the left, and plate B is moving to the right, and you can also show it is happening because of the convection currents from the mantle, right? You can also show this over here. And so I just complicated this subduction zone. You need not write. I was what basically I was.
Sir, that's actually that's where I got doubts.
Yeah. I tend to complicate things. No need to do this at all. Not needed at all. Subduction zone and all. So you can just show plate tectonics. Plate tectonics. Oceanic ridge. It is divergent. We have written a plate. This is also plate. And why it is moving? Because of the, you can term it here, convection currents. And you can also write. Well, this much is enough. Okay. So what type of questions you can expect from this? The question is regarding more further research you guys have to do about. We are playing at a very advanced level. This advanced level, when you will be doing, right, post your prelims and before your mains you will be doing, and we are doing it now. So imagine the kind of advantage you will be having over other aspirants. So don't get intimidated. Enjoy this process, the difficulty level. So you can further research about the hot spots. Again, previous year question about mantle plumes, and Pranchu was talking about volcanic islands, how they are from archipelagos and all. Example, the Hawaiian island, right? You can then there are some very easy questions like convergent boundaries, subduction zones. Okay, and again when we come to the Indian geography, we will be studying the concept of Deccan traps and all. Okay guys, I think that's it from my side. If you guys have any questions or anything to say, you can say, otherwise we can meet again tomorrow.
So one more thing, sir. Shall
Yes, sir. Please go ahead.
Yeah, actually, so I'm being new to this mains group. I don't know whether you are sharing this or not. Are you sharing this whiteboard or?
Yes, definitely. I will share it right away.
Okay, thank you.
I'll share it right away. But I think you have to download this Microsoft Whiteboard. I usually do it in OneNote. OneNote was easier. You need not download anything. But I don't know why I did it in this today. I will share it right away though. Okay. Okay guys, you have my number. You can call me anytime or text or call Chitra ma'am if you are having any doubts. So let's meet tomorrow. Okay guys. Okay. Thank you
Yeah,
and good night.
Thank you. Good night.
Thank you, sir.
Thank you.